I wanted to talk a little bit about this whole concept of ions and just briefly go over the positive and negative ions. Ions again are charged atoms or atoms with a charge, and basically when we're talking about charges we're talking about pluses and minuses. Atoms are neutral, ions have a charge. It's just like an atom except it has a charge. And you remember we create charges by altering the number of electrons. We have three particles: protons, neutrons, and electrons. Protons and neutrons are not changeable in this realm. Nuclear chemistry they are. In this realm we're only able to change the electrons. Because we're not doing nuclear chemistry, we're doing more traditional chemistry here. So how do I create a positive ion? A positive ion or positively charged ion. How do I accomplish that? Well, in order to become positive, I have to lose my negativeness. So you do this by deleting or subtracting electrons. And I know it's a little bit, we see the plus, we think addition. It means positive charge, doesn't mean addition. Because it's a little backwards than that, It's a little backwards than our thinking of arithmetic, that something that's plus is actually from subtracting. But I would rather you stay out of the math idea and more of the physics idea of charge. How do I become a negatively charged ion? Well, you become negative by adding negativeness, by adding electrons. And when you look at the periodic table like we have in the background here, certain regions of the periodic table have atoms that create ions of a certain charge. And we've seen this over and over again, but something like oxygen turns into a -2. And the reason it does that is, if you remember our classifications, our noble gases on the far end are very, very, very stable. They have a complete full valence. Their electron configuration is complete. There's no gaps. There's no half-filled or partially filled blocks. And when my oxygen picks up 2 electrons, all of a sudden it has an electron configuration that is the same. Its configuration is now the same as neon's. Because it jumped twice over to neon. Picked up 1 electron would be fluorine. It doesn't do that though. It doesn't pick up 1. It picks up 2 electrons. And when it does that, it now has the electron configuration of neon. It's achieved a certain degree of stability, just like the noble gas neon. Now, is my oxygen now neon? No. It's still a type of oxygen, but it's an oxygen with a charge. And I said oxygen does not just pick up 1 and look like fluorine, have the configuration of fluorine. And it doesn't lose electrons and become positive and look like nitrogen or carbon, or even go backwards all the way to helium. It only does one path. It does the path of being -2. In order to have the electron configuration of neon. Pick another one. Iodine. Iodine picks up a -1 charge. So iodine becomes I -1. Oxygen turns into O -2. Pick another one. We'll say phosphorus. Phosphorus comes into play at a -3. And you can probably see the pattern here. Different areas of the table develop certain charges in order to achieve that noble gas configuration. And it doesn't really work in the middle of the table, but it does work on the ends. Such as strontium. Strontium, first of all, strontium does not pick up a bunch of electrons to assume Xeons configuration. In fact, it goes the opposite. It's the path of least resistance. It's the easiest path. To get to a noble gas configuration, it's not going to gain a bunch of electrons. How much is that? Maybe 16-ish electrons, 16 electrons to come all the way to Xe. It will actually go backwards and become positive 2. Okay, because it's going to go jump and then jump again. Okay, it's going to jump and then jump back again, and that will be to Kr. Okay, it's not written over here. It's written over here as the noble gas Kr. So all in all, certain areas of the table have certain charges, and the reason they actually develop those charges is to assume that noble gas configuration. I'm putting the staircase in just to show that, okay, the halogens turn -1, all of them. If they're neutral, but when they have a charge, they're -1, -2, -3. We rarely see these, but -4 and -5. Okay, we usually never deal with those. Usually it's just the 3, 2, 1, -1, -2, -3. Again, the reason is that they do that. Okay, those particular atoms pick up 1 electron. Okay, the halogens pick up 1 electron to get that noble gas configuration. The oxygen, sulfur, selenium, and tellurium pick up 2, and so on and so forth. I put the staircase on because they actually stop at the staircase. Okay, they stop at the staircase. So they don't extend all the way down. What I mean by that is aluminum does not become a -5. It stops at the staircase. Metals are on this side. They go positive. Same thing on this end. Okay, this column of alkaline metals is positive 2. And this column of the alkalis and hydrogen. Hydrogen is not an alkali metal, but I'm going to put it in there anyways. Is positive 1. Okay. And you know what? Let's just keep it the alkalis. I'm going to leave hydrogen off. Okay, these ones turn into positive 1. Hydrogen also achieves a positive 1 charge, but it does it for a little bit different reason. It doesn't get an He configuration. It goes actually to no electrons. But that's neither here nor there. Okay, so when I say the different areas of the periodic table that have specific charges, this is basically what we're talking about. And let's talk briefly about isoelectric. Okay, I just erased it. Let me put this back in. +2. +1. Okay, isoelectric means the same electronic configuration. I'm just going to pick one randomly. I'm going to pick a noble gas of krypton. Krypton has 5 different things that have the same structure as krypton. Okay, altogether it would be 6. Okay, what I mean is isoelectric, same structure. You have krypton, bromine -1, because it picks up 1 electron to have krypton's configuration. If you don't believe me, draw it. Se -2 goes over twice, same configuration as krypton. As -3, okay, same configuration as krypton. Over here, Rb +1 and Sr +2. Okay, all 6 of these, we have the krypton atom, and all 5 ions have the same configuration. They are all iso, okay, iso meaning same, isoelectric. Electric meaning electrons. Okay, so they're all isoelectric. They all have the same configuration. And you should be able to pull that off for any noble gas. If I asked you to come up with a couple of isoelectrics for 2 additional isoelectrics to neon, okay, you'd have a bunch of choices. Okay, if you're doing neon for isoelectric, it could be F 1 minus, okay, or minus 1, O minus 2, N minus 3. You could do carbon and boron. I prefer not to. Okay, I'm going to do Na plus 1 and Be plus 2. And again, I don't do boron and carbon as much because we don't really see them as often. I would actually take them, though. I would have no problem taking B minus 5 and C minus 4. But we don't really see those in this class. Okay, so all of these ions, these 5 ions, would be isoelectric to neon. Isoelectric, again, meaning same electronic or electron configuration.